Alright, let's go ahead and continue our discussion on multiplying and dividing radicals. Remember that in order to do this, these are going to be the things that we want to look at. We want to know how to multiply monomials, and we need to be able to factor numbers. So in this section, we're going to not only combine radicals, but we will split them up as well. So the first thing that we're going to want to do is multiply the insides so that there is only one root. From there, we're going to simplify the radical by splitting it into two groups. The first group will have perfect squares. The second group will have the leftovers and should contain no squares. Finally, we want to take the square root of the first group, keep the second group inside the square root, and bring down to the final answer. The only difference between these examples, again, and what we looked at in the last presentation is that we're going to be doing both. We're going to be doing both combining and splitting up. Alright, so let's look at some examples. We're going to start with 50x, with the square root of 50x to the 7th. First thing that I want to do is, this is already combined, so we want to go ahead and separate. So we're going to separate this into two things. I want squares and non-squares. So 50 can be divided by 25. 25 is a square. I'm going to put it in my first set. And 50 is equal to 25 times 2, so I'm going to put 2 in my second set. For the variables, remember that we want the largest even number that is less than the given exponent. So the largest even number less than 7 is 6. This is going to go in my square group. And I have 1 left over in my non-square group. So now if we go ahead and take the square root, we get the square root of 25 is 5. X to the 6th, if I divide by 2, I get x cubed. And I still have my 2x on the inside. If we go ahead and try to do this with factoring, what multiplies to 50? We get 2 and 25. 25 is 5 and 5. I have a pair of 5s, so I can pull out a single 5, that's my number on the outside, and I have a 2 that cannot be paired up. That one stays inside the square root. Okay, now what about x to the 7th? If I write out 7 x's, how many groups of 2 can I make? I can make 1, 2, 3 groups of 2. So that is where I get my x cubed on the outside. I still have 1 left over that cannot be paired up, and so that will stay inside. Alright, let's look at example N. This is going to be an example where we're going to combine and separate. So the first thing I want to do is multiply my insides together. If we do this, we get 15 times 3 is 45. X to the 6th times x to the 7th, I'm going to add my exponents, and so I get 13. Okay, if we go ahead and separate this, what is a square that divides into 45? Our answer is 9. 45 is equal to 9 times 5, so I'm going to put 5 in my other set. What is the, now if we look at the x, what is the largest even number less than or equal to 13? That is going to be 12. So I'm going to put 12 x's in my first set, and I have one left over for my second set. All right, let's go ahead and take the square root of the first set. Square root of 9 is 3. Square root of x to the 12, if I divide by 2, I get x to the 6th. And I leave my 5x inside. If you want to do this using factoring, 45, what multiplies to 45? I get 9 and 5. 9 is 3 times 3. So we have one pair of 3's that is going to go outside. I'm going to pull 1 3 out. We have a 5 left over that has nothing to pair up with, and so that is going to stay inside the root. And now if we look at x to the 13th, I want 13 x's. I think that's 13. And we go ahead and pair them up. So we've got 1, 2, 3, 4, 5, 6. That becomes my exponent on the outside. We have x to the 6th. I have 1x left over with nothing to pair up with, and so it stays inside. Okay, so there are some more examples of multiplying and simplifying radicals. So now let's go ahead and talk about dividing radicals. So our procedure, if it is not already a single root, we want to combine it and simplify the fraction if possible. From there, we're going to split the square root into two groups. Again, our first group will be our perfect squares, and our second group will be the leftovers. Then we take the square root of the first group, keep the second group inside the square root, and bring down to our final answer. So notice that the only thing that really changes on this is when we combine, we're going to be dividing. So let's go ahead and look at some examples. So just like with multiplication, we can also combine or separate our square root when we have a fraction. So for instance, if I look at the square root of 49 over 25, the first thing that I want to do is split my root up. So I'm going to put my root with the 49 with the top. I'm also going to put my root on the bottom with the 25. And now we just want to simplify each one of these smaller roots. Square root of 49 is 7. Square root of 25 is 5. And we're done. Okay, let's go ahead and look at another one. For this problem, we have that our square root is already separated, and so when we start with a separated root, the first thing that we want to do is combine. So when I combine this, I get the square root of 48 x to the 5th over 3x. Let's simplify the fraction. So I'm going to divide my numbers. 48 divided by 3 is the square root of 16. And remember that when we divide, we subtract the exponents. So we get 16 x to the fourth. Now this one is already a perfect square. 16 is a square and x to the fourth is a square. So we do not need to separate it, we just need to simplify it. So the square root of 16 is 4. And the square root of x to the fourth is x squared. If I write out x to the fourth, we can make 2 groups of 2. And so that is going to be my new exponent on the outside.